Is there life beyond Earth? A question that has haunted humanity since we first turned our gaze to the stars. This age-old query has driven our exploration and innovation, leading us to gaze upon our cosmic neighbor, Mars, with an insatiable curiosity. Mars, that fiery red orb hanging in the night sky, has captured the imagination of scientists, philosophers, and dreamers alike. As the fourth planet from the Sun, and seemingly the most Earth-like, Mars presents itself as our best shot at answering the cosmic question. Is it possible that this barren, rugged world, with its ancient canyons and icy polar caps, once harbored life? Or better yet, could it still? With the latest rover missions and cutting-edge research, we are on the brink of potentially discovering the unimaginable. And so, our journey begins, not in the distant future, but in the past. The first missions to Mars were not the successes we hoped for, yet they paved the way for future exploration. The path to understanding Mars was not always a smooth one. In fact, the first attempts to reach the Red Planet were met with a series of challenges and setbacks. The initial voyages, launched in the early 60s, were a combination of trial, error, and pure determination. Missions like Mars 1 and Mars 2, ambitious in their scope, unfortunately, didn't reach their intended destination. Technical hiccups, communication failures, and the unforgiving nature of space travel resulted in these missions missing Mars entirely. But as the saying goes, failure is often the stepping stone to success. And that success came in the form of the Viking programs launched in the mid-70s. Viking 1 and Viking 2 were the first missions to land a spacecraft safely on Mars, marking a monumental achievement in space exploration. These missions were not only a testament to human ingenuity and resilience, but they also opened up a whole new world of possibilities. The Viking missions provided us with our first real glimpse of Mars. They gave us detailed images of the Martian surface, revealing a landscape both alien and familiar, with its rocky terrain, vast valleys, and towering mountains. The Viking landers also conducted a series of experiments, searching for signs of life, and while the results were inconclusive, they sparked a curiosity that has fueled further exploration. Despite the hurdles faced by the early Mars missions, each one played a crucial role in advancing our understanding of the Red Planet. They taught us valuable lessons about the complexities of space travel and the harsh realities of a Martian environment. They allowed us to dream bigger, to look further, to question deeper. These early endeavors laid the groundwork for a new era of Martian exploration. Without them, our current understanding of Mars and our ongoing quest to unlock its secrets would not have been possible. They were in many ways the stepping stones to the future, the pioneers of a journey that continues to this day. With the dawn of the 21st century, we entered the era of Mars rovers, sophisticated mobile laboratories designed to unlock the Red Planet's secrets. And so, our journey through the Martian landscape truly began. We started with Pathfinder and its little companion Sojourner, the first successful Mars rover mission back in 1997. Their mission was to demonstrate the feasibility of low-cost landings on and exploration of the Martian surface. This dynamic duo provided us with an unprecedented wealth of information about Mars' geology and atmosphere. Then in 2004, Spirit and Opportunity arrived. Twin rovers, they were tasked with finding signs of past water activity on Mars. Spirit might have had a troubled journey, but it gave us stunning insights into the rich mineralogy of Mars, including the discovery of iron-rich spherical formations nicknamed blueberries. Meanwhile, Opportunity outlived its original mission lifespan by 14 years, revealing compelling evidence of ancient Martian environments that could have supported life. Fast forward to 2012, and Curiosity takes the stage. The car-sized rover was equipped with an array of sophisticated instruments to assess whether Mars ever had an environment able to support small life forms. And boy did it deliver! Curiosity discovered that Gale Crater once held a lake with conditions that could have supported microbial life. It also detected organic molecules and seasonal variations in methane levels, further fueling speculations about potential life on Mars. These rovers, each more advanced than the last, have transformed our understanding of Mars. They've shown us a planet with a diverse geological history and a climate that has changed dramatically over time. They've discovered ancient riverbeds and deltas, evidence of long-gone lakes and minerals that could only form in liquid water. They've given us a glimpse of a world that, in many ways, is not so different from our own. But the most intriguing question remained unanswered. Is there, or has there ever been, life on Mars? The search continues, and with every new discovery, we inch closer to solving one of the greatest mysteries of our time. Water, the lifeblood of our planet, could it exist on Mars? The answer would prove more complex than we ever imagined. In the heart of our cosmic neighborhood lies Mars, a world of red dust and mysteries. For years, scientists have been fascinated by the idea of water on Mars. Water, as we know it, is the cornerstone of life. If we could find water on Mars, then perhaps we could find life. The search for water on the red planet has been a tale of intrigue and discovery. Early missions to Mars revealed a world with a thin atmosphere and temperatures far below freezing. It seemed unlikely that liquid water could exist here. Yet, as our rovers and satellites peered closer, they began to unveil a different story. They found evidence of ancient riverbeds and lakes etched into the Martian surface. These geological features suggested that Mars was once a world with flowing water, much like our own. They hinted at a time when the Martian atmosphere was thicker, warmer, a time when life could have thrived. In the polar regions of Mars, our spacecraft uncovered vast reserves of water ice. This ice, locked away in the Martian soil, could be a valuable resource for future human missions to Mars. It could also hold clues about the planet's past and its potential to harbor life. But the hunt for water on Mars didn't stop there. Scientists discovered signs of hydrated minerals and seasonal flows of salty water on the Martian surface. These findings pointed to the possibility of liquid water existing on Mars today, albeit in a form very different from the flowing rivers and lakes we have on Earth. The question of water on Mars is no longer a question of if, but how much and where. Each new discovery brings us one step closer to understanding the history of water on Mars and the possibility of life. Water on Mars, a tantalizing clue in our quest for life, but the search was far from over. In our search for life, we looked not for little green men but for something much smaller, microbes. These tiny single-celled organisms may seem insignificant, but they hold the keys to understanding life's existence and evolution. When we talk about the search for life on Mars, what we're really talking about is the search for microbial life. The Mars Science Laboratory, or MSL, has been instrumental in this quest. Through its Curiosity rover, it has analyzed Martian soil and rock samples for signs of past or present microbial life. The findings? While definitive proof remains elusive, Curiosity has discovered complex organic molecules and fluctuating methane levels in the Martian atmosphere. Tantalizing hints that Mars may once have been hospitable to life. But the quest doesn't stop there. Enter Perseverance, the latest rover to join the Martian exploration team. Perseverance's mission? To seek out signs of ancient life and collect samples for possible return to Earth. It's equipped with state-of-the-art instruments designed to detect biosignatures or signs of life in the Martian rocks and soil. Every sample it collects could potentially answer the question, did life once exist on Mars? Yet, the importance of these microbial mysteries extends beyond Mars. Microbes are the most abundant form of life on Earth. They've been around for billions of years, evolving and adapting to every conceivable environment. By studying potential Martian microbes, we might learn more about our own origins and the nature of life itself. So, as we continue to probe the red planet's secrets, remember this. It's not just about finding life on another planet. It's about understanding life in all its forms, in all its places, from the tiniest microbe to the largest galaxy. It's about expanding our knowledge and, in turn, expanding our perspective. The quest for life on Mars is more than a scientific endeavor. It's a testament to our insatiable curiosity, our longing to understand our place in the cosmos. As we stand on the brink of a new era, what does the future hold for Mars exploration? The coming years promise an exciting flurry of activity. From advanced robotic missions to the first steps of human explorers, Mars is set to take center stage in the cosmic theater. NASA's Artemis program aims to return humans to the moon by 2024 as a stepping stone for future Mars missions. Meanwhile, SpaceX's Starship, under the ambitious vision of Elon Musk, is gearing up to carry humans to the red planet within this decade. These missions aren't just about planting flags or leaving footprints, they're about pushing the boundaries of our knowledge. They'll probe deeper into Mars' potential for life, past or present. Every rover track, every drill hole, every sample returned could bring us closer to a grand revelation. As we continue to unlock the secrets of Mars, we inch closer to answering that age-old question, are we alone in the universe?